In today's lecture, let's review for exam 3. Question 1, we want to give the ordered pairs that are solutions and graph the equation. If I look at this equation, this is the equation of a line, and in order to graph this, we're going to pick some points. We want to use x equal to 0, and we'll plug that into the equation. We have 3y equals 4 times 0 minus 12. And I can solve for y. 4 times 0 is clearly 0, so we have 3y equals negative 12. Divide both sides by 3. I have y is equal to negative 4. So we can plot the point 0, comma, negative 4 on the graph. And here's the point 0, comma, negative 4. For the other coordinate, we have the y is equal to 0. So we're going to use the same equation, but this time we're going to plug in a 0 for y. 3 times 0 is 0. And 0 is equal to 4x minus 12. I can add the 12 to both sides. And that gives me 12 equals 4x. We could divide both sides by 4, and x is equal to 3. This allows me to plot the point 3, 0. And here is the point 3, 0. Now we could plot more points if you want to, but this is good enough for us. We can just plot a line on the graph, and this is our solution. We have a line that has a y-intercept of 0, negative 4, and an x-intercept of 3, 0. Question 2. For the equation y equals x squared minus 8, let's create a table with at least 3 ordered pairs that are a solution of the equation. Here they gave us x equals negative 2, 0, 2, and all we have to do is plug in negative 2 for the x. So let's try it. We have y equals negative 2 squared minus 8. Again, I'm just replacing the x with negative 2. We can simplify this. That's negative 2 squared gives me 4. 4 minus 8 equals negative 4. So that's the first ordered pair. I can plot negative 2, negative 4 on the graph. We could do it again. We could plug in a 0 this time. We have y equals 0 squared minus 8. This simplifies to y equals negative 8. Then we could plot 0, negative 8 on the graph. For the last ordered pair, we're going to substitute x equals 2, y equals 2 squared minus 8, and 2 squared is equal to 4. 4 minus 8 is equal to negative 4. Let's plot 2, negative 4 on the graph. And this does give us the graph of a parabola. And it should face up because the leading coefficient here is a positive 1. So we know this is a parabola that faces up. Question 3. Match the following equation with its graph. To do this question, we'll have to look at the standard form for a circle. Recall x minus h squared plus y minus k squared equals r squared. This will allow us to find the center of the circle. The center of the circle is h, k. And h, k is located here. H is positive 5 and k is positive 4. Look at the formula. This is x minus h. So the 5 is h. Don't make the mistake that h is negative 5 and k is negative 4. That's a very common mistake. H is actually positive 5 and positive 4 is k. Now what is our radius? Our radius is going to be the square root of 25, and that's 5. So we'll have to find a graph that has the center of 5, 4 with a radius of 5. And the only option is option C. Question 4. Decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it does not, describe the graph. Let's start by rearranging the equation. Let's subtract 25 to both sides. I have x squared plus 10x plus y squared plus 6y plus equals negative 25. Now notice that I put the x's right next to the x's and I'm leaving myself some blank spaces. The reason for this is we're going to complete the square. That's why we need to leave some blank spaces. Now recall the formula for completing the square is b over 2 squared. In this case we have b is 10. So we have 10 divided by 2 squared. That should give us 25. That means I have to add 25 here on the left, but you also have to add 25 on the right to compensate for that, to make sure the equation is still equal. Now we need to complete the square for the second part, the y part, and we have b is 6. So b divided by 2 squared is 6 divided by 2 squared, which gives us 9. I need to add 9 on the left, and I'll also have to add 9 on the right to compensate for it. Now we can complete the square twice. This factors as x plus 5 squared. Again, the shortcut is to take the b divided by 2, and that's how we get this 5. X squared plus 10x plus 25 is just factored as x plus 5 squared. I could do the same thing for y squared plus 6y plus 9. We take that b, we divide it by 2, so this factors as y plus 3 squared. And on the right side here we have negative 25 plus 25. They're going to cancel out, and so we just get a 9. This is an equation of a circle, so we can state the center. The center is going to be HK. But remember, it's opposite of what you think because the formula is x minus h squared plus y minus k squared equals r squared. So h is actually negative 5 and k is negative 3. And our radius is going to be the square root of 9, which is 3. So this is a circle centered at negative 5, comma, negative 3 with a radius of 3. We had to complete the square twice for this question. Question 5, determine the range. The range is essentially the output of our relationship. So in this case, the output is the y coordinates. The range is just the set of all the y coordinates. That would be 2, 9, 12. The domain would be the input or the x values. The domain would be 4, 8, and 10. Question 6, use the graph to determine open, the key phrase here is open intervals on which the function is increasing. That means we're going to look at where the function continues to rise. If you look at the graph, notice it is a parabola facing down, but it's increasing from the left side here, so that's all the way to the left. That's from negative infinity, and it keeps going up and up and up and up and up, and it stops here when x is equal to 0. Then it starts decreasing back down. So this is an increasing function from negative infinity, comma, to 0. In the directions, they want open intervals, so make sure you use open intervals. This is our solution for question 6. If we wanted a decreasing interval, we would look from 0 to infinity. It decreases as soon as we get above x equals 0. Question 7, let g of x be equal to negative x squared plus 4x plus 3. We want to simplify g of negative 4. This means I have to plug in a negative 4 everywhere I see an x. So let's plug in a negative 4 everywhere we see an x, and then we'll simplify. Negative 4 squared is a positive 16, but there's a negative in the front, so we'll bring down a negative 16. plus 4 times negative 4 plus 3. Now we can do the multiplication. 4 times negative 4 is negative 16. We have negative 16 minus 16 plus 3. Let's do addition or subtraction from left to right. Negative 16 minus 16, that's negative 32 plus 3. And this simplifies to negative 29. Notice I only write g of negative 4 once, and we are lining up our equal sign. Make sure you show your work just like this. Question 8, use the graph of y equals f of x to find each function. Part A, let's find f of negative 2. This means the input or the x coordinate is equal to negative 2, and I want you to find the output or the y coordinate. If you look on the graph, we have the point negative 2 comma 0. The x is negative 2, the y is 0. So f of negative 2 is equal to 0. For part B, we're looking for f of 0. Again, the x would be 0. So this has a coordinate of 0, comma 4. The x is 0. What's the y coordinate? The y coordinate is 4. For part C, we have f of 1. And if you notice on the graph, there's the ordered pair 1, comma 2 on our graph. So f of 1 is going to have an output of 2. Finally, for part D, we have an x coordinate of 4. And we want to figure out what the y coordinate is. This is the point 4, comma 4. So f of 4 is equal to 4. Again, we're looking for the output. They gave us the x coordinate. All I need to find is the y coordinate. And we're just looking for the y coordinate or the ordered pair that works for our function. Question 9, state the open intervals over which the function is increasing, decreasing, and constant. Notice we have the function decreases here. It's going down, down, all the way to x equals negative 2. So I have a decreasing function from negative infinity to negative 2. We want open intervals, so every interval that I'm going to use is going to be open. Notice now that from x equals negative 2, it starts rising, and it stops here at x equals 5. So it's going to be increasing from negative 2 to 5. Again, notice we're using open intervals because we're talking about open intervals only. It's increasing when x is negative 2 up to when x equals 5. And it's constant. It's constant from x equals 5 to infinity. This is a constant function. There's no rise or fall from x equals 5 to infinity. Question 10, write an equation of a line described. Give your answer in standard form. Recall standard form is ax plus by equals to c. We have the point 2 comma 9. I'll just label this as x1, y1. And the slope is given as negative 7. When we want to write an equation of a line, we always use this formula. Y minus y1 equals m times x minus x1. Now let's plug in the values. We know y1 is 9, so we're going to have to write y minus 9 equals m, which is negative 7, times x minus x1, which is 2. And all I have to do now is simplify. We can distribute the negative 7 here to the right. That's negative 7x. And negative 7 times negative 2 is positive 14. Let's add the 9 to both sides. We have y equals negative 7x plus 23. Now this is the equation of a line in slope-intercept form, but we want standard form, so we need to rewrite it in ax plus by equal to c form. So I need to add the 7x to both sides, and I could write this as 7x plus y equals 23. That's standard form. So make sure you're careful, write it in standard form, or the computer will mark your solution as wrong. Question 11, write an equation of a line. Again, I'm going to use the formula y minus y1 equals m times x minus x1 every single time I hear that phrase, find an equation of a line. Now we have 2 points here, negative 2 comma 1 and 6 comma 2. We want our solution to be in standard form, but we need to find the slope first. In order to find the slope, let's use the formula m equals y2 minus y1 over x2 minus x1. I'll label this as x1, y1, x2, y2, and we'll plug in the numbers. y2 is 2, y1 is 1, and x2 is 6. We have a double negative here, so be careful. This is 6 minus a negative 2. Then we can simplify the slope. The numerator is 1, and since this is a double negative, we're going to do addition. 6 plus 2 is 8. So the slope is 1 over 8. We have the slope, that's what we need, and we know what x1, y1 is. So let's plug it into our equation now. Y minus y1 is 1. That's equal to 1 over 8 times x minus, again we have that double negative, so be extra careful with that double negative. This is actually a plus sign. Y minus 1 equals, we can distribute, this is 1 over 8x plus 1/8 times 2 is going to be 1/4. Now let's simplify it a bit further. Let's add the 1 to both sides. We have y equals 1 over 8x plus 1 over 4 plus 1. That's going to give us a fraction. Let's do the work on the side. 1 plus 1/4. I can collect common denominators. 1 can be written as 4 over 4. And so this is 5/4. So 1 plus 1/4 is 5/4. And this is our solution in slope-intercept form. But we want it in standard form, so a nice trick is to find the LCD. The LCD of 8 and 4 is 8. So I can multiply everything by 8. Let's multiply everything by 8 to get rid of all these fractions. This gives me 8y equals x plus, we can reduce this to a 10. So we have 8y plus x plus 10. Now to get this in standard form, we need to subtract x to both sides. Let's subtract x to both sides. I have negative x plus 8y equals 10. And just to make this a little bit better looking, you could multiply everything by negative 1 or divide everything by negative 1. And you can simplify this to x minus 8y equals negative 10. This is our solution in standard form. Question 12. Write an equation A in slope-intercept form and B in standard form for the line passing through 2, 6 and it's perpendicular to 3x plus 5y equals 1. The first step is to find the slope of a line that's perpendicular. So we'll start with 3x plus 5y equals to 1, and I'm going to write it in slope-intercept form. This will allow me to read the slope of this line. So let's subtract the 3x to both sides. I have 5y equals negative 3x plus 1. Divide both sides by 5. We get y equals negative 3/5 x plus 1/5. Now all we're concerned about is the slope. What is the slope of this line? The slope of this line is negative 3/5. But I don't want to use this slope. I want to use a slope of a line that's perpendicular to this. So the slope that I'm going to use is the negative reciprocal of negative 3/5, which is 5/3. I want to use the slope that's perpendicular to this equation. So let's use 5/3. If it was parallel, we would use the same slope. But since it's perpendicular, use the negative reciprocal of this slope. Let's use our formula. Y minus y1 equals m times x minus x1. Here we know m is 5/3. 2, 6 will be our x1, y1. We have y minus 6 equals 5/3 times x minus 2. x1 is 2. Now let's simplify this a bit. We'll distribute the 5/3. We have y minus 6 equals 5/3x. 5/3 times negative 2, that's negative 10/3. Now this equation has a lot of fractions in it. To get rid of it, let's multiply everything by 3. Let's multiply every single number here by 3 just to get rid of all these fractions. This simplifies to 3y minus 18 equals 5x minus 10. Now we can simplify it a bit. Let's add 18 to both sides. So we have 3y equals 5x plus 8. We can divide everything by 3. And so we have y equals 5/3 x plus 8/3 is the equation of our line that is perpendicular to 3x plus 5y equals 1 and passes through the point 2, 6. This is known as slope-intercept form. To write this in standard form, we can go back to this step here. We have 3y equals 5x plus 8. We have 3y equals 5x plus 8. To write it in standard form, we have to subtract the 5x to both sides. We have negative 5x plus 3y equals 8. And we want the x to be positive. It just looks better. So let's divide everything by negative 1. We have 5x minus 3y equals negative 8. Now this is our equation in standard form. We have it written as ax plus by equals c form. So know the difference between standard and slope-intercept form. They're very similar. They're just written in a different fashion. Question 13. Graph the piecewise defined function. We have f of x is equal to 4 plus 2x if x is less than negative 4. So I'm going to plug in some values. Let's check at x equals negative 4. We're going to plug it into 4 plus 2x. We have 4 plus 2 times negative 4, and that's going to give me 4 minus 8, which is equal to negative 4. So let's start our graph. We're going to plot the point negative 4, comma, negative 4 first. That's going to be located here. 1, 2, 3, 4. 1, 2, 3, 4. Now I'm going to use an open circle because we have a less than symbol. It is not included, so we're going to use an open circle. Now let's pick another point. Let's pick something to the left of negative 4. Let's pick x equals negative 5. And I'm going to plug it into the same equation, 4 plus 2x. We have 4 plus 2 times negative 5. That's equal to 4 minus 10. And I get a negative 6. We expect the equation 4 plus 2x to be a straight line, and it is. We're going to plot the point -5, -6. So you can see it's going to be a line that has an open circle at this endpoint. So that's it for all of the values of x minus 4. I can definitely pick more points, but we know it's going to be a point on this line. Let's look at -4 to 5 here when x is equal to -4 to 5. Let's plug in the values into -2x. Let's check x equals -4 first, and I'm going to plug it into the equation -2x. -2 times -4 is going to give us a positive 8. So I need to plot the point -4, 8. And here is the point, -4, 8. Let's pick another point between. Let's say x equals 0, something easy to calculate. -2 times 0 is equal to 0. So I'm going to have to plot 0, 0, the origin. I expect the equation -2x to also be a line, so it makes sense that we're going to have a line, but I want to focus on the endpoint here at x equals 5. At x equals 5, that's -2 times 5, I get -10, so I need to plot 5, -10. Now this has to be a closed circle because of these less than or equal symbols. So let's plot the 5, -10 ordered pair, and that should be a closed circle. This is the point 5, -10, and it is a closed circle. So let's make sure we connect these lines together, and they both should have closed circles at the endpoints. For the last part of the graph, we're going to plug in values of x that are greater than 5 into the equation 3x. So let's plug in x equals 5 into 3x. That's going to give me 15. So I need to look at the point 5, 15, but this will be an open circle because this is strictly greater than. So let's plot the point 5, 15. This is the point 5, 15, but this is going to be an open circle, so let's make sure this is an open circle. And we know 3x is going to be also a line, so let's pick another point. Let's say x equals 6. 3 times 6 is equal to 18. So my graph looks something like this. We'll have to plot the point 6, 18. And we're going to have a point somewhere up here. This is the point 6, 18. So this is a rough sketch of our graph. We have the equation 4 plus 2x for values of x that are less than -4. There's an open circle here. And then it makes a jump. We have a solid line, -2x from -4 to 5. And then we have another jump here. And this is the equation 3x for x greater than 5. So to do these piecewise divide functions, just plot some points and be careful at the end points. Sometimes they're open circles and sometimes they're closed circles. So just look at the inequality to figure out if they're open or closed. Question 14. Fill in the blanks to correctly complete the following sentence. To obtain the graph of f of x equals x plus 4 cubed minus 9, shift the graph of y equals x cubed to the left blank units and down blank units. Let's figure out what the standard form for the cubic function is. Recall f of x is equal to x minus h cubed plus k. This h is going to shift our graph to the left or right, depending on if it's positive or negative. And this k is going to shift our graph up or down, depending on if k is positive or negative. Notice Yes, Mom?
Oh, you're doing work stuff?
Yeah. Notice in the equation we have h is -4. So we're going to shift the graph 4 units to the left. H is equal to -4. And k is equal to -9. That's going to cause our graph to shift down 9 units. So be very careful. H is opposite of what you think, but k is what you see is what you get. This graph is going to be shifted to the left 4 units, and it's going to be shifted down 9 units. Question 15. Without graphing, determine whether the following equation of the graph that is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. To determine if something is symmetric about the x-axis, I need to replace y with -y, and if I get the same equation, then it's symmetric about the x-axis. So let's give it a try. We have x squared plus -y squared equals 13. And this is x squared plus y squared equals 13. It's the exact same equation. So it's got to be symmetric about the x-axis. It's got to be. To check to see if it's symmetric about the y-axis, what I need to do is plug in x equal to -x. And if I get the same equation, then it's got to be symmetric about the y-axis. Let's plug it in. We have -x squared plus y squared equals 13. This simplifies to x squared plus y squared equals 13 again. Yeah, that's the same equation. So yes, it's also symmetric about the y-axis. Now to check for symmetry about the origin, I have to substitute x equals -x and y equals -y. And if I get the same equation, then yes, it's symmetric about the origin. We have -x squared plus -y squared equals 13. And what do you know? You do get the same equation back because -x squared simplifies to x squared, -y squared simplifies to y squared. So yes, this is also symmetric about the origin. So it's all three of these symmetries, which kind of makes sense because we're talking about a circle. This is a circle centered at the origin, so it's symmetric about the x-axis and is also symmetric about the y-axis. So that makes perfect sense. Question 16. Decide whether f is even, odd, or neither. To find if some function is even, we'll have to replace x with -x, and then we will end up with f of x back. That would define an even function. If it's an odd function, if I replace x with -x and I get negative f of x back, that can be considered an odd function. And if it's none of those cases, well, it's got to be neither. So let's try it out. Let's plug in a -x into the function. We have f of -x equals -x to the fourth minus 4 times -x squared plus 9. Again, I'm just plugging in -x into our x values. -x to the fourth simplifies to x to the fourth, and -4 times -x squared simplifies to -4x squared plus 9. Now, if you look at our original function, we have f of x equals x to the fourth minus 4x squared plus 9, and that's what this is equal to. So we just proved f of -x is equal to f of x. Therefore, this is an even function. This is an even function. In question 17, let's graph the following function. We have x plus 10 cubed. Recall our cubic function generally looks like this. F of x equals x minus h cubed plus k. Notice here we have h comma k is equal to -10 comma 0. There's an invisible plus 0 here on the right. So hk is going to give us the inflection point. So this is basically the same as our cubic function. Our parent graph f of x equals x cubed is the general graph that we want to copy, but what's happening? We're just going to shift it to the left. It's going to be shifted to the left 10 units. So it's just like the standard cubic function, but it's shifted to the left 10 units. So we have something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is our inflection point. And we have that cubic function that looks like this. So it's just shifted to the left 10 units. Question 18, let f of x be equal to 4x squared plus 5 and g of x be equal to negative 4x plus 2. Let's find f minus g of negative 2. To do this question, we'll find f minus g of negative 2, and that's the same thing as f of negative 2 minus g of negative 2. So let's plug in a negative 2 into f of x. That's going to be equal to 4 times negative 2 squared plus 5. And I'm going to subtract g of negative 2. G of negative 2 is substituting a negative 2 into g of x. That's negative 4 times negative 2 plus 2. Now I'm extra careful here. I'm extra careful when I subtract g of negative 2. I want to ensure that there's a parentheses around the entire thing, g of negative 2. This forces me to subtract the whole thing and not just part of it. So be careful with that. Make sure you have a parentheses around g of negative 2. Let's simplify. This is 4 times negative 2 squared is positive 4. We have a negative here. And negative 4 times negative 2, that's a positive 8. And then we could simplify the inside of the parentheses. This becomes 4 times 4 plus 5 minus 8 plus 2 is going to give us 10. Now we can do the multiplication. 4 times 4, that's 16, plus 5 minus 10. And we'll do addition from left to right. This is going to give us 21 minus 10. And that simplifies to 11. So our solution is 11. Question 19. Without using paper and pencil, evaluate the expression g of f of 1. Recall g of f of x is equal to g of f of x. So we're going to plug in the entire f function into g. Now for this case, we're looking for g of f of 1. G of f of 1 equals g of f of 1. So what that means is we're going to plug in a 1 into the f function, and then whatever we get from that, we're going to plug that into the g function. Let's find f of 1 first. F of 1 equals 1 plus 5. Here I'm just plugging in a 1 into the f of x function. 1 plus 5, that's equal to 6. We know f of 1 is equal to 6. And we're going to plug that 6 now into g of x. So we have g of 6. We'll plug in a 6 into g of x, and that's going to be 6 squared. 6 squared here gives us 36. So g of f of 1 is equivalent to 36. Question 20. For the function f of x equals x squared plus 5, we'll find f of x plus h first. In part A, we're looking for f of x plus h. What that means is I'm going to plug in the x plus h into x squared plus 5. That gives me x plus h squared plus 5. I can simplify this. x plus h squared is just the same as x plus h times another x plus h. Now you want to do the scratch work here on the side. I'm going to have to FOIL this out, so do that scratch work on your own. But you should get x squared plus 2xh plus h squared when you FOIL this stuff out. And so that's part A, that's f of x plus h. For part B, I'm looking for f of x plus h minus f of x. F of x plus h minus f of x. Well, we know what f of x plus h is. We did it in part A. So let's just copy that part. That's x squared plus 2xh plus h squared plus 5. Now the next part of it is to subtract f of x. That means I'm going to subtract the entire f of x function. That's x squared plus 5. This gives us x squared plus 2xh plus h squared plus 5. We'll have to distribute the negative. That's negative x squared minus 5. I can see what simplifies. Notice the x squareds, they cancel out, and the 5s cancel out. That's 2xh plus h squared. So that's f of x plus h minus f of x. That's equal to 2x h plus h squared. Now for part C, we're going to finish off the problem. We're looking for f of x plus h minus f of x divided by h. But we already know what the top is. We've done that in part B, which is pretty nice. We'll plug in 2x h plus h squared on the top, but we gotta divide by h. Notice the numerator can factor. We could take out the h. Take that out, we have 2x plus h left over, and that's over h. You see what simplifies? The h's, they divide out, and this simplifies our equation to 2x plus h. That is our difference quotient. Now this doesn't seem that important yet, but when you get to calculus, this is a very important concept.